Welcome back, everybody. This is part 3 of 4 in my lecture series on graphing rational functions. If you haven't seen the first 2 parts, please go and watch those first. In this video, we're going to learn how to identify and find slant asymptotes for rational functions. Let's get started. A slant asymptote is very similar to a vertical and horizontal asymptote, except that this time instead of vertical or horizontal lines, these are lines that have a slope. And these show up when the degree of the numerator is exactly one more than the degree of the denominator. The slant asymptote in that case is Q plus R over D, where Q is the slant asymptote. Here, this is just performing the division that shows up in that rational function. With all the letters and symbols floating around, this looks a little complicated, so let's try some examples. In part A, notice the degree of the numerator is 2, which is 1 plus the degree of the denominator, or 1. That's how I know this has a slant asymptote. So how do I find the slant asymptote? Well, I perform the division. I need to find x squared minus 1 divided by x. And now hopefully it's clicking why we're talking about this idea next. I can do that through long division or synthetic division, since this term is degree 1. But I prefer to use long division, so that's what I'm going to use. X divided into x squared minus 1. I can fit x copies of x into x squared, and I get x squared. I'm going to subtract everything off, bring down the negative 1. And I'm already done. Negative 1 is my remainder. So I would write x squared minus 1 over x as x minus 1 over x. So this guy is my slant asymptote. I have a slant asymptote of y equals x. Go ahead and pause the video here to see if you can tackle parts B and C on your own. I found a slant asymptote of y equals x in part B and y equals x minus 2 in part C. And here's how I did that. In both cases, notice the degree of the numerator is 1 larger than the degree of the denominator. In part B, I've got degree 2 on top, but 1 on bottom. So I perform the division, and I get x with the remainder 1. So I can rewrite this rational as x plus 1 over, that should say 1 over x minus 1. Here, the quotient x is my slant asymptote. Same thing over here, but here I've got degree 3 on top and 2 on bottom. I perform that long division, and the quotient I get is x minus 2 with remainder 4x plus 1. So I rewrite my rational as x minus 2 plus 4x plus 1 over x squared plus 2x, and that quotient is my slant asymptote. In this video, we saw how to calculate slant asymptotes of rational functions. In the next video, we're going to put it all together so that we can actually start sketching some of these graphs. Catch y'all in the next one.